What's going on, everyone? Homework assignment 32. Today's objective, I can multiply and divide monomials. All right, so let's go with the definition first. So when we say monomial, it's an expression with, that's not a word, and it's an expression with one term. Okay, so for example, 80 is a monomial, x is a monomial, and 8x is also a monomial. All right. The only thing that's going to separate terms is going to be something like a plus or minus sign. So let's say if I had the expression 80 plus 8x, this whole expression is no longer a monomial. This is actually what we would call a binomial, but we'll just stick with monomials for now. So here are the rules. So we have three rules that we're going to follow. First is the product of powers property. It says that when we multiply powers with the same base, so right now our bases are a and a, so the bases are the same. Multiply powers with the same base by adding their exponents. So we add their exponents and we keep the base. So a to the power of m times a to the power of n is a to the power of m plus n. So we keep that base and we add the exponents. So for example, 2 to the power of 4 times 2 to the power of 3 is going to be 2 to the power of 4 plus 3, which is 2 to the 7th. Quotient of powers property, we divide powers with the same base by subtracting their exponents. For example, a to the power of m divided by a to the power of n is a to the power of m minus n. And in this case, we're saying where a is not 0. All right. So example would be 3 to the power of 6 divided by 3 to the power of 2 would be 3 to the power of 4, which is 3 to the power of 6 minus 2, which is 4. It could also be written like this. So 3 to the power of 6 divided by 3 to the power of 2 is 3 to the 4th. All right, I guess we'll just stick with those two properties for now. And we'll use another one as we go. All right, so let's go ahead. Let's find each product. And we're going to express the answers using positive exponents. All right, so let's go. So 4 to the 3rd times 4 to the 5th. Well, I'm multiplying, so I'm going to keep the base the same, and I'm going to add the exponents. So that's going to be 4 to the power of 8, and we could leave it evaluated like that for now. Second one, 6 times 6 to the power of negative 4. So be careful with this because you could get tricked. 6 does have an exponent. We just don't see it. And the exponent that 6 is raised to is a 1. All right, so that means that it's going to be 6 to the power of 1 plus negative 4, which is going to be 6 to the negative 3rd. And I want to express it using a positive exponent. So that's going to be 1 over 6 to the 3rd. Last one. R to the 6th times r to the negative 5th. Well, that's r to the 6 plus negative 5, which is going to be r to the 1st, or I could just say r. All right, let's keep it going. Dealing with the product rules. 2x to the 3rd times 8x to the 4th. Well, if we have coefficients of our variables, we can multiply those coefficients by each other. So this is going to end up being 16x to the, so now the basis of x is going to stay the same, and I'm going to add the exponents, x to the 7th. All right. Next one, same deal. I'm going to multiply the coefficients. So negative 3 times 2 is a negative 6. Times n to the power of negative 9 plus 8 is going to be a negative 1. So here's how I'm actually going to rewrite this one. So it's just, remember, it's just n to the negative 1st power. So this is going to be written as negative 6 over n. I could say n to the 1st, or I could just say n. I'll leave it as n to the 1st for now. But that's what my final expression is going to be. The whole expression is going to be negative. If you were asking a question about that, the whole expression will be negative, not just the 6. So just everything in the expression is going to be negative. All right, last set, we're going to deal with some division problems. All right, 8 to the 5th divided by 8 to the 3rd. Well, we know that that means 8 to the 5 minus 3, which is going to be 8 to the 2nd. All right, d to the 5th divided by d to the negative 2nd. Well, we know that that's going to be d to the 5th minus negative 2. Yes, not just 5 minus 2, but 5 minus a negative 2, which is going to be d to the 7th power. 5 minus a negative 2 is 7. Lastly, we have 2 to the negative 2 second power. 2 to the negative 2nd power divided by 2 to the 2nd power is going to be 2 to the negative 2nd power minus 2, which is going to be 2 to the negative 4th, which as a positive exponent would be 1 over 2 to the 4th. There it is. Check out practice problems. I'll see y'all in class tomorrow.